Deforestation is often imagined as a sudden and visible act. A tree is cut, a fire spreads, a forest disappears. But this way of thinking is too simple, and it hides the real nature of the problem. The loss of forests does not begin at the moment trees are removed. What we see in those moments is only the final stage of a much longer process, one that develops slowly across economic systems, supply chains, and environmental changes. To understand deforestation properly, it has to be seen as a system, not an event. At the global level, forests are under pressure because of land demand. Land is needed for agriculture, livestock, mining, infrastructure, and urban expansion. Among these, agriculture is the main driver. Studies estimate that around 80% of global deforestation is linked to agricultural activities, especially cattle ranching, soy production, and palm oil plantations. This demand does not come from one place. It is distributed across global markets. Beef produced in one country may be consumed in another. Soy grown in South America is often used as animal feed in Europe or Asia. Palm oil appears in processed food, cosmetics, and cleaning products worldwide. This means deforestation is not only a local issue, it is part of a global economic network. From an economic perspective, forests are often seen as unused land. Converting them into farmland or industrial zones can generate fast financial returns. This creates a strong incentive for land use change, especially in developing regions where economic growth is a priority. However, this short-term gain ignores the long-term value of forests. Scientifically, forests are complex ecosystems that provide critical functions. One of the most important is carbon storage. Trees absorb carbon dioxide from the atmosphere and store it in their biomass and in the soil. When forests are cleared or burned, this carbon is released back into the atmosphere. Deforestation is responsible for about 10 to 15% of global greenhouse gas emissions, making it a major contributor to climate change. But carbon is only one part of the story. Forests also regulate the water cycle through a process called evapotranspiration. Trees release water vapor into the atmosphere, which contributes to cloud formation and rainfall. Large forest systems such as the Amazon influence weather patterns across entire continents. When forests are removed, this system weakens. Rainfall becomes less stable. Dry seasons become longer. In some regions, this can lead to a shift from forest ecosystems to drier systems like savannas. This kind of shift is not always reversible. Another key concept in understanding deforestation is forest degradation. A forest does not need to be completely cleared to lose its ecological function. Activities like selective logging, road construction, and small-scale mining can damage the structure of the forest. These changes reduce biodiversity, disrupt animal habitats, and make the forest more vulnerable to further damage. Over time, a degraded forest becomes easier to clear completely. This leads to another important process, habitat fragmentation. When forests are broken into smaller patches, ecosystems become less stable. Animal populations are isolated, which reduces genetic diversity and increases the risk of extinction. Edges of forest patches are more exposed to sunlight, wind, and human activity, which changes local conditions. Fragmented forests are also more vulnerable to fires. Fire plays a critical role in many deforestation processes. In some regions, forests are intentionally burned to clear land. In others, degraded forests become dry enough that fires spread more easily. Once fires begin, they can create feedback loops. Burning releases carbon, which contributes to warming. Higher temperatures and lower humidity make future fires more likely. This cycle can continue, pushing the ecosystem towards collapse. In the Amazon, scientists have warned about a tipping point. If deforestation reaches a certain level, often estimated around 25 to 26% of total forest area, the system may shift permanently. Instead of a dense rainforest, large areas could become dry, open land. Current estimates suggest that parts of the Amazon are already close to this threshold. Historical data shows how quickly deforestation can scale. For example, in Brazil, deforestation rates increased rapidly during certain periods due to expansion of agriculture and infrastructure. Policies and enforcement have reduced rates at times, but the pressure remains constant because the underlying demand has not disappeared. Globally, the world lost about 10 million hectares of forest per year between 2015 and 2020, according to international data. That is an area roughly the size of a large country disappearing every year. But these numbers still don't fully capture the complexity of the issue. Deforestation is not only about trees, it's about biodiversity. Forests contain about 80% of the world's terrestrial species. When forests are destroyed, many species lose their habitats. Some can adapt or move, but many cannot. This leads to a loss of biodiversity, which reduces the resilience of ecosystems. Lower biodiversity makes ecosystems more fragile. They become less able to recover from shocks like climate change, disease, or extreme weather. There's also a human dimension. Millions of people depend on forests for their livelihoods. Indigenous communities in particular have deep connections to forest ecosystems. When forests are cleared, these communities lose not only resources but also cultural and social structures. At the same time, global demand continues to grow. This creates a difficult balance between economic development and environmental protection. My view is that one of the biggest problems is how we define value. In many systems, the value of a forest is measured only when it is cut down, when timber is sold or land is converted. The ongoing ecological services of forests, carbon storage, water regulation, biodiversity, are not fully included in economic calculations. This creates a structural problem. It makes deforestation seem profitable, even when it causes long-term damage. If we want to address deforestation effectively, the focus cannot be only on stopping tree cutting. It has to include the systems that drive it: global supply chains, consumption patterns, and economic incentives. For example, reducing demand for products linked to deforestation, such as unsustainable palm oil or beef, can lower pressure on forests. Certification systems and regulations can help, but they require transparency and enforcement. Technology can play a role too. Satellite monitoring now allows real-time tracking of forest loss. This improves accountability, but it doesn't solve the root causes. At the individual level, actions may seem small, but they're part of a larger system. Every product has a supply chain. Understanding where products come from and the impact they have can influence demand over time. The goal is not to eliminate consumption, but to make it more aware and more selective. Deforestation is not a single moment in time. It's a process that develops through economic decisions, environmental changes, and human behavior. By the time trees fall, the system has already moved in that direction. If we want to change the outcome, we have to look earlier at the forces that make deforestation possible in the first place. That's where the real fight begins.